case we need it. And P.S. your 10-2 is now online. Okay. Could we actually, though, if we were trying to do near 0, could we do something like 0.1 and actually plug it into this one, whereas if we were to plug into the other one, the limit as x approaches 0 of e to the x minus 1 all over 2. If we were to actually plug in 0.1, this one would have to be an approximate, we'd have to guess. This one we'd actually be able to get a fractional answer, right? Does that make sense? We could actually solve, because it's a polynomial, as opposed to this one, e to the 0.1, I don't know, something like ish, right? So that's the difference between being able to approximate or use the Taylor polynomial, because we can do math with the third degree Taylor polynomial a lot easier than we could with the exponential. Or I should say it without approximating. But in this case, kiddos, when are these two the exact same?
At 0.
So if we're trying to limit as x approaches 0, then we're totally fine. They will be the exact same, meaning it will meet, the expressions will meet at x equals 0. The expressions will meet at x equals 0. And they will be approximations
Why isn't there an x next to the 2? Is it like a...
Oh, I was just writing it quickly from memory. I didn't actually look up to see if they were supposed to be next. So, the functions are going to meet at 0. They're going to be approximates as you approach 0, but a limit doesn't really care about whether or not it's a little bit off as you come in towards it, right? So we can say the limit of both are the exact same.
So if we wanted to find e to the e squared, we would plug in 2 for all those x's, right? Like e to the x equals 1
True,
plus
but
2
then we have to ask ourselves the question, would the polynomials be a good approximation at 2? Now, we haven't specifically talked about this, the interval of convergence. You haven't actually been asked it for e to the x. We haven't shown like why or how it is what it is. But in the book in section 10.2, it does state for us that the Taylor series for sine and cosine and e to the x do converge to the functions for all real numbers. So the interval of convergence would be all real numbers in the sense of as you expand the terms. So there is no set interval of convergence. The reason I'm saying this, though, Gerardo, is if this was the function 1 over 1 minus x and you said at 2, that could be a very bad approximation because the interval of convergence is only between 1 and negative.
because it's 1 minus. Like why does it change from all real numbers to from later?
Well, they're two very different functions. We're talking about e to the x in this one, and then the other one we were talking about 1 over 1 minus x. But if you think about it, the 1 over 1 minus x, as we kept expanding that, it was expanding somewhat. Like it was getting closer and closer and closer, but only between 1 and negative 1. But when we saw yesterday, where is he? Here he is. Sine, wasn't that a marked difference between the intervals of convergence? Does that make sense?
Yeah.
Like it was getting markedly wider and wider as we go. And that's just a graphical representation of what can be mathematically proved once we get to, I think, to section 10.4. But that's just sine, and then that's why I said we haven't mathematically proven the interval of convergence, because we've only talked about that for geometric series. But it is stated in section 10.2, the Taylor series for sine, cosine, and e to the x, the interval of convergence is all real numbers.
Since it's all real numbers, so you can't use a Taylor series to prove e to the I pi plus 1 equals 0. Since I is not a real number, you can't use a Taylor series to like.
Yeah, I don't think it'd be necessarily helpful, although I don't know exactly how it's been proven. Like, I saw it once and I'm sure whatever, but it didn't stick. So, that might be a part of it. I don't remember it being a part of it, but. I did want to show you guys one quick, or have you read, wrong way. One quick thing from the book that you guys probably wouldn't read unless I pointed your attention to it. So I thought it helped give, yeah, I know, a bit, here we go, more context to what we're doing. And the nice thing is, it also relates to literature, which is kind of fun. Can I get that? Alright, ready, set. Can I make this big full screen again?
Oh, you click the. Oh.
There we go, I got it. Go! Read. You there, give me a thumbs up. So why did I bring this up when we're talking about the interval of convergence? Now, first of all, I thought it was pretty cool, just the idea of Euclid alone has looked on beauty fair. But besides that, the second to the last paragraph, we still must remember that convergence is an infinite process. In our minds, it might be too easy to limit that idea. Yes, it is converging, but it is an infinite process. Even the 1 billionth order Taylor polynomial. What does that mean, 1 billionth order? What would x be raised to? What power?
1 billion.
1 billionth degree, right? But that will begin to peel away from sine of x as we move away from 0. Peel away. Kind of like we saw on the graphs that I was talking about just a second ago. Stink. Can someone go hit F11 on the keyboard? Thanks, try. Try escape by being F11. Thanks. With the graph that we were talking about, is it still up there? It's not. You guys know what they mean by peeling away, right?
Oh, it starts to go away from it.
Yeah. The easiest one that I can see real quick is this one. Because in the sense of we see it right here in the inner, and then it peels away. There we go. Coming back. Imperceptibly at first and eventually becomes unbounded. What does it mean by unbounded as far as a polynomial?
Like it works for all real numbers.
Works for all real numbers, but also sine is infinitely bounded between 1 and -1, but all polynomials should be unbounded. Now, all even polynomials will be unbounded in the same direction, right? So it could be from like a minimum to infinity or from a maximum to -infinity, but they're still unbounded. Or all odd functions like the one that you see here are going to be unbounded in opposite directions, which would be infinite. So they're saying, okay, even the 1 billionth, it's going to be following for a long time on that sine curve, but eventually it is going to go to infinity and -infinity. Nonetheless, we can approximate the sign of any number to whatever accuracy we want. We just have enough patience to work out the terms. And then the last paragraph, this kind of dramatic convergence does not occur for all. This is kind of letting you guys know that even though sine, cosine, e to the x, and maybe others have infinite intervals of convergence, once again, certain ones like Ln will never converge outside the interval from -1 to 1. So how would we once again make it converge around where we want it to converge? If our value is not naturally in between -1 to 1?
We want it to converge. Mm-hmm. If you divide the function by something?
No. just center it somewhere else? We can center it around the value that we want to approximate. Does that make sense?
Yeah.
All right. Coming back to our notes. Anyway, cool quote and cool description of what's going on. I think we finished this one basically, right?
Is
The
that
limit
what-
ends up equaling what?
One half. No, you have to do
1/2, right?
Mhm.
Sorry, it took me a second. My brain kind of like spazzed out for a moment. Okay. Here we go. There's some very good AP questions in this homework, so we're going to try to be working to that end. I didn't pick all of them, even though I wanted to pick almost all of them, but this will still help. Gerardo, go.
Is that how a calculator does their signs and stuff?
The calculator programming is largely based upon Taylor-Maclaurin series, yes. So like in AB, when I talked about, was it AB? Yeah, when I talked about IVT and how like positives to negatives, there are zeros in between, and so one way of finding a zero, and I said possibly the old programming and calculator used it. If you want to find a zero using the second trace command, you give a negative, you give a positive, and one way to find it would be to use the bisection method, and so for the computer to try all the different calculations of pick a value, is it positive or is it negative, pick another value, is it positive or is it negative, and then try to narrow it down more and more and more. That was not as efficient of a way. Remember efficiency in computer programs, right? They took too many steps. It was not as efficient of a method as using Taylor series. Or if you think about the slide rule, perhaps this is what the slide rule is built upon as well.
Yes.
Because Taylor series can be used to approximate to whatever degree of accuracy you would desire a sine, a cosine, an e to the x, etc. So possibly hidden figures when you had Catherine, right? When Catherine Johnson? Yeah, that was her name. When she was a computer and she was able to do analytic geometry, solving for sines and ln's and cosines and e to the, etc. with a certain degree of accuracy, and at the end when she was up on the chalkboard, don't worry, I'm not giving away the whole movie, but you should watch it. She went up, oh no, she checked the calculations. Maybe he'll live, maybe he'll die. John Glenn, we know he landed on the moon, so never mind. But anyway, she was able to calculate it. The IBM was a new thing. She calculated to more decimal places of accuracy. Anyway, it opens up a whole new world. P sub 2 of x, what's it talking about? Oh, they tell us. A second degree Taylor polynomial, yeah? What can you say about the signs of A, B, and C if f has the graph pictured at the right? Wait, what? Ooh.
It looks like ln of 1 plus x.
Ooh. Don't go that far. Don't go that way. Look at it. What can we say about the signs of A, B, and C if f has the graph pictured at the right? How on earth do A, B, and C relate to f? This is a whole new, make sure everyone's totally focused in, AP problem, new type. How does A, B, and C relate to f? This is a whole new type of, how does the f prime relate to the f in our graphs? This is a whole new type of that. Yeah, coefficients. Who is A?
The first term.
How do I find the first term of a Taylor polynomial? Because it says about, right? Who's B going to be? Does that make sense? Who's C going to be?
F double prime over.
Woo! Way to catch that. Many people forget it. A is f of 0, B is f prime of 0, C is f double prime of 0 over 2 factorial. Now, wait, what? How are we supposed to? Oh. Okay, so hold on. What is f of 0?
1.
Who knows? Doesn't matter. What are they asking for? it's up. So hence I can say, since f of 0 is greater than 0, then a is greater than 0. I know I'm possibly restating. Let me go ahead and change these all to decimals. Is that okay? Decimals, sorry, colons. I know, it's a struggle. F prime of 0, what do I know about it?
It is concave.
Too far. Ah, f is increasing, therefore f prime is positive. F double prime, now Georgie.
Concave down.
So therefore f double prime is?
Less negative.
Done to the left hand. That's
So
a
would they
fun.
give this with actual values though?
Not necessarily. Remember, they can give you graphs as representation. Could they also give you values? Yes. Cool dealio. So even Taylor series can be asked graphically or can be tested graphically, and the answer is yes. So wait, can it also be tested numerically, like with a table or with given values? And the answer is also yes.
Oh,
Don't worry, not yet.
disgusting.
What? How? That wasn't disgusting. Wasn't that an easy one? I wouldn't mind
Yeah,
that for
but
an
the
FRP.
I hate tables.
That'd be multiple choice, actually.
You had me going.
I know.
You had me going. I was super excited, and then you shot me down. You tell me more choice.
List the first four non-zero terms of the Maclaurin polynomials for f of x is equal to sine, cosine, and e to the x, and then use them. Use them? Well, hold on, wait a minute. Before we use them, we better write them. So what do we know, guys?
Nothing.
Who? Wait!
It's centered at 0. It's Maclaurin.
No. Who's sine of x?
X.
Plus.
Not plus.
Oh,
Minus.
first one's minus.
Minus x cubed over 3 factorial plus x to the 5th over 5 factorial.
Dot.
The fourth term is 7.
Yes. It is. No. The,
Yeah.
Yeah. Technically, because the other terms.
Yes.
Why did I put equals? This is the question I was asking a second ago. Why did I put equals and not approximate?
Because.
Because it's a series.
Because you're
Oh,
on
Because it's a series. I made it plus dot. Who's cosine going to be?
It's gonna be x.
Wait, why
X
wouldn't it
starts
be
it off.
an equal? Why wouldn't it be an approximate?
Because it keeps going. If you take out the plus dot, then it would be
If it's
approximate,
cut- yeah, if
because
it's
then
cut
you go all
down.
the way through.
So I'm not necessarily doing the piece of 4 of x right now. I'm just showing you the infinite series. Does that make sense?
Yes.
The infinite Taylor series. Technically Maclaurin series. Who's cosine? If you don't know, you should say, oh, easy. Cosine is the what of sine?
Derivative.
Exactly. So derive them.
Ooh. But I want to derive the next one.
Yeah.
Can we derive the next one?
Wait, isn't derivative of 3 factorial just 0? Because it's constant, yeah.
It's a coefficient, buddy.
Constant multiple. So 3x squared. So 1 or 2 x squared over 2 factorial. Boom.
Why?
Because
Bring down the 3 and the 3 and the 3 factorial becomes a 2 factorial.
Yeah.
Now he's done. What's the next one going to be? Bring down the
next
5
one
and the
is gonna
5
be
cancels?
X to the 4 over 4 factorial. The next one's going to be x to the 6 over 6 factorial. Boom.
How can you check to see if we're right?
Calculus, ask me this and she said we're right. So
Nope.
okay.
Go to your graphing calculator. I want you to graph cosine. I want you to graph. Let's just do all 4 terms. Do the 4th degree Taylor polynomial.
That is Miss D.
Oh, come on. Where are your
I didn't bring
calculators? You
it.
still didn't bring them?
I brought it yesterday.
I'm not judging you, Ethan. I'm judging the rest of them.
Hey, I have a calculator.
I met Jackie and George who exchanged books. So they didn't have it.
I said it wrong at first.
Question. Does anybody know if your apps randomly disappear besides finance? What's gone wrong? What?
She said it.
We've tried. It's
Really?
Caleb's. Yeah. I've reset. I've restored to like the defaults. I've restored them all. I don't know what else to do. I think I have to like Google. Right? It should work. That's what I was thinking.
Like if you But like you click the back button. That's so weird.
Memory management.
I rebuke you in the name of Jesus. Try it now.
What is that? Apps? Let me just try to reset the apps.
No, don't stop pods again.
Dean?
I'll go beat up
No, Dean's a good kid.
Sometimes.
I like him.
He's alright.
What do you think, Manda and Gerardo? Is it cosine?
I'm still writing this down.
I hit graph button to zoom 6 and it's still it's going out.
What do you mean by hit factory? What? Oh, I thought you said hit back then. I was hoping there was some shortcut I was missing.
It looks really weird. I don't really know what's happening.
We're supposed to graph a polynomial, right?
Is it cosine?
Yeah. No?
Oh. I don't like cosine.
X minus.
Do I have to do weird parentheses? Probably. I'm gonna do one.
Doing that, right? Am I crazy?
Yeah, but I didn't put parentheses around, so that might be one.
I don't think you really need a parentheses.
I do because I don't have it where it goes in a fraction.
Gerardo, does it look like cosine?
I know I can do that, but I
Oh,
didn't
okay.
put them like that.
I'm still writing it in. That's. Yeah, I got this. Don't worry. Graphing.
Meanwhile, as they finish,
Oh, here we go.
who's e to the x? We talked about him the other day.
Yeah.
No, it does not look like cosine.
Or well, 1 times 4 because the 4 is there.
Wait.
Or what?
Oh, did I really?
Remember, isn't e to the x his
So
own
1
derivative?
plus e to the x
We
plus e to
did
the
the
x
same
plus e to the
thing.
x plus e to the x plus e to the x. And when you plug in, since it's centered at 0, wait, no. I can't remember. We did something, it turned out to be 1 or something.
We missed you did the same thing again.
Plus x to 4.
Wait, so e to the x is the same as 1 and 1 minus x.
So what's wrong? How else can we check it?
Minus
How do we form Taylor polynomials?
With magic.
Using a simple one.
Hmm.
Plugging in.
x to the
Yep.
6th over 6.
Who's my friend?
There's one.
Who's my
Okay.
double friend?
That is what mine looks like.
Okay. It's deep. It does look like cosine, but only up to a point. Yeah. It looks like a cosine, but like only up to like a certain point. Otherwise, it just looks like some weird x to the 4th function.
Why? Why does it only look like some weird
Because we only put
even
in
function?
It's an approximate.
It's a polynomial. What type of polynomial is it?
A quartic.
An even polynomial. Of course he's gonna look like an even polynomial. Does that make sense?
Yeah.
Yeet.
So, for those of you guys that missed the coolness, if you're thinking about cosine and sine, they only go between 1 and negative 1. So depending on your window, do you want the window way zoomed out? No, probably not. E to the x is 1 plus x squared plus x cubed. Remember, because... Oops, hold on. Struggle. E to the x... Ugh. E to the 0 is 1. Wait. Hold on, that doesn't work. Isn't it over 2 factorial over 3 factorial? Did I just forget that? Okay, so the first one that we did was cosine. And that was 1 minus. I won't do too many, don't worry. Can I show them the struggle? Why is x graphing? Where's factorial?
Math left 4.
Isn't it in a nice little like
No, because you don't have
For
the
us it is.
Oh, sad day, I'll scroll down.
Sorry, Mom.
That's okay.
Forgive me.
If you do second to the right, it skips you to the end.
Second to the right? What do you mean there's only one right?
Well, like if you're on the graph and you have a long polynomial, you can use second right, and it like jumps you to it's like
Oh yeah, I know.
h right.
I think it's number 9 under.
No, it's probability 4.
Oh, thanks.
That's what I said.
I haven't got the true yet. There we go.
That's what I said.
So wait, how do you do second then?
Like okay, do second.
Oh, second that way?
Yeah,
Oh,
and it
that's
skips you
cool.
to the end of the cursor.
That actually is very beneficial. I'll just do one more. So
I
that's the
don't know anything about my calculator.
I learned everything I know from my calculator about Miss D and then trying to get A's on tests.
I don't know why.
Like there are so many like things that
Yeah,
I
that are like
no
hidden.
clue.
Sometimes I
You're
feel like I
right,
know too much
you're
about my
right.
calculator.
I
Like
think quite well.
nerd.
So what they were seeing was they were like, oh wait, hold on, I'm in a weird pre-cal window for like some crazy constraints. Zoom standard. Okay. They were like, I don't get it. It's just like a even function. Oh wait, I see it pretty good.
Wait, how come yours is positive?
I only did x to the fourth. I didn't go up to x to the sixth. Is it cosine? Yes, but for how long? Well, not super far, right? Because we only have a fairly small approximation. But does it start at 1? Yes. Does it go, oh, hey, it does look like cosine. Dun, 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 dun. Okay, now hold on, wait a minute. Which one did I just say was e? Or they said thought it was e. 1 plus x squared. Is it e? How are we going to know? Plus x
Hopefully it is.
Oh, you can use your special limit and do it that
plus
way.
x.
No.
To the fourth? Oh no,
Wait.
what happened? Don't worry, I'll use my cool little second over. Favorite thing ever.
That's so cool. How did you find that out?
I know that's like so helpful.
I'm telling you guys, just gotta YOLO.
How do I have this? Oh, I was
Literally YOLO.
messing with the calculator and I noticed like that this thing has like a second feature,
Twice.
and I hit second right and it went. I was like, oh.
Now, if only they could automatically after a power go down. Anyway,
I know.
Well, I mean, but then you would never be able
is it E?
No.
Not even.
Oh, maybe.
Oh.
Ooh.
Is it?
I don't know. This one doesn't look like E, but I only did it to like 4
Ooh.
Maybe it's E. So if you
Maybe
zoom
it's
out.
A, B, C.
And then, oh, I don't want that.
Why not?
How did you know to approximate E that way, Miss D?
I wrote it down and I was like, oh, because we talked about it in class the other day, didn't we?
Yes,
I don't recall.
It was one of the examples that we did because we expanded it. Where's E to the X? Can't see it. Is it, oh, ln, because that's E. That makes sense. X. Does it match?
Oh, the LN thing? Yeah. Still don't know that.
I don't know.
What happens if we go a little bit further?
Last.
Oops, second, right, what? Go team. Plus x to the power of 5 over. Plus x to the power of 6. Then they expanding even further.
No, I went to the 7.
How gangster does he look?
It's still
Ah.
super close.
Shoot. 6.
I'm trying to remember if it's e to the.
You useless pussy.
I'm trying to use my memorization technique, but it's not working super well. We haven't made our endeavor card out of it yet. We know that e to the x, e to the x, e to the x, e to the x, and we're trying to find it at 0, right? So e to the 0 is 1 plus e to the 0 is, that's the derivative, 1 times x, plus e to the 0 is 1 times, we forgot our 2 factorial. That's what's wrong. That was right.
Oh, well, aren't we just.
So go throw in over 2 factorial, over 3 factorial, over 4 factorial. There we go. All better. Now guys, how do we use these? How do we use these to find the first 4 non-zero terms of the polynomials down below A, B, and C?
You plug in, instead of x, you plug in 2x. Or non.
Exactly. So we can say P sub. Wait a minute. The first 4 non-zero terms. Oh, struggle. What degree polynomial is that going to be for letter A?
For the first 4 terms, it would be,
Why is it P sub
7?
7?
Every other one.
Because technically, if you did expand it, it would take 7 degrees in order to get to this expansion, right? We're just shortcutting because we know what sine of x is. So we're like, sweet, you know what? Every other one is going to be a 0, so it's going to cancel out. Does that make sense? And that's expanding on the idea that we saw yesterday, that just because there are 4 terms does not mean it's a 4th degree. Similarly, just because it's a 7th degree does not mean there will be 7 terms, because maybe some will be 0. You guys keep on going for B and C.
B and C.
where you get stuck. Nah, don't get stuck. Because what do you do?
Just keep
Just
swimming. Just
If
keep
cosine
swimming.
is just a polynomial, or we're using cosine's Maclaurin polynomial approximation, can't we just distribute the x in? Right? So it's going to be p sub, why am I saying p sub 6? Even though I'm going to write x minus x cubed over 2 factorial plus x to the 5th over 5 factorial minus x to the 7th over 6 factorial. Yeah, my factorial went wrong.
Oh, yeah. How are we doing, Sam?
How come it's
Distributed into x.
yeah.
But it's a 6th degree because, didn't we use a 6th degree cosine polynomial? Now technically if you're thinking about special, even though this exercise doesn't use it, we might go ahead and put in 1 minus 1 over x. Isn't he the... Wait, why does it make sense that he's the... Where are his factorials? Isn't he just the geometric times x times x times x times x? There's no factorials needed, right? If I were you, you might want to take a quick picture of that. That's going to eventually be a forever card there, or sorry, an endeavor card. Technically not until we really start talking about series. We haven't really talked about the series. I mean, I have, but the book is more talking about polynomials. But eventually we'll have this guy memorized. Hey, real quick, memorization. Mnemonic device. Sine. Is he an odd or an even function? He's odd, right?
What does it mean? Odd function?
What kind of symmetry does he display in his graph? Is he origin or is he y-axis?
I never know.
He's origin.
Odd.
Whereas cosine,
Even.
yeah.
Hey, maybe this is.
Come on, you know this. Why?
Odd even.
Because
it starts at the top.
an odd function like a cubic displays the same type of symmetry, and an odd function like a parabola, an even function like a parabola displays the same type of symmetry. Yeah? Long story short, hold on. Why did I just bring all that up? Sine has what kinds of degrees? Odd. Cosine has what kind of degrees? Hey, way of remembering. Okay, coming on back. Did you guys finish the other one?
Now I'm gonna learn symmetry.
Nice.
You just said symmetry.
Go team. Ah, I just said 10. Hold on. What are we doing for letter C?
Turning up.
Putting in x squared everywhere and then multiplying it in 4, right?
P sub, we're gonna fill in that in a second. We are gonna multiply everything by 4. So we can leave him on the outside if we want, distribute him in later. And if we're just doing the first 4 non-zero terms, what degree polynomial is it gonna be? Yeah, because it's the 3rd degree, right? And I'm going to go ahead and plug in, instead of x, I'm going to plug in x squared. So what's the 3rd term going to be?
X to the 4th
Good.
over 2 factorial.
What's the next term going to be? X to the squared cubed? Power to a power u?
Multiplying.
Got it, 6. So if we want to finish it, we can go ahead and just put in a 4 to everybody. Does that make sense? These are all little baby puzzles. We just got to figure them out.
You know what puzzles go?
In a
There's
puzzle
a
book.
closet on the top shelf collecting dust.
I think the 3rd one is just 2. It's like the 4 and the 2 factorial cancel out.
Oh, it could be. Sorry, I wasn't simplifying.
It's okay.
Oh!
Put on, yay! Next section.
Is anything more fun going to show up in homework?
I hope not.
Yeah, I don't know either.
We obviously know it will.
I know, but
Because you had to ask that question.
I know, but like you just gotta pray that she's yoking with us.
Yoking?
They cannot change.
Do not be unequally. Life lesson. Okay.
Well, you're unequally yoking me with some hard stuff over here.
That's what the Bible principle was talking about.
Well, I'm just saying, I'm unequally matched and yoked with this homework.
How do you do it in pen?
What?
Your work?
Your notes?
I do my notes in pen,
Question!
but I do the homework in pencil.
Yeah, I don't know.
Question.
Because I don't want it to like smile.
Thank you. Look at number 22 and 23. They can give you a graph and ask about Taylor and Maclaurin. They can give you numeric data and ask you about Taylor and Maclaurin. But didn't we do that yesterday?
Yeah.
Okay, so you guys said it was all like scary. It's not that bad, right?
So it
It's
was
the formula.
hard this
Question. Look at 24, 25, and 26. Can they give you FRQ-ish types of things with Taylor and Maclaurin?
That's easy right there.
That's easy right there.
Come on, easy peasy lemon squeezy.
George.
Yes.
We
Number
should do it
24.
together to show how easy it is
Number
to Joyce.
24 is in your homework.
Don't you think it was easy?
Oh.
We should show Joyce how easy it is.
Number
And
24
put it
is in
together
your
right now.
homework.
I forgot.
So question. How are we supposed to find f prime of 0 and f to the 10th power of 0 if they don't even tell us who f is?
Derive those thingies.
Use my special formula that I came up with.
That's what you're going to do.
Can't you derive the terms?
We can. Do you want to drive it 10 times though?
But I don't know how to do. I can do the first one, stop the 10th.
We don't want to drive the 10.
So how do we do it?
You tell me.
If I could, I would.
This is a Maclaurin.
Oh, I know.
Who's in here?
Me.
For
Aren't derivatives in there? Who does this represent?
F0.
Uh-huh. Who does this represent? Wait, who?
F prime of 0.
Wait, where is f prime of
Oh,
0?
Oh, snap.
Wait,
So you just have to expand to the 10th term?
but wait, where's f prime of 0? I
It's
don't
1.
see him.
What do you mean is that the
It's
term?
not 1 because f prime of 0 is over 1 factorial, not 2 factorial.
Oh, 0 then.
So 1 over 2 factorial must be f prime of 0? Right? This should have just been a 1. This shouldn't be a 1 over 2 factorial. So who's here?
The F double prime?
No.
F.
Okay, hold on. Think of your formula. For x to the 0. For x to the 0, right?
Yes.
And if we're looking at our expression, okay. For x to the 0, that's f of 0, right?
Mm-hmm.
For x to the 1, that's f prime of 1 over 1 factorial. It's not there, so whatever coefficient is there must have been the prime. For x squared, who's there? Oh, struggle. Hold on. What would f double prime be? We better figure out a pattern, else we're going to have to go all the way to the 10. F double prime is supposed to be over 2 factorial, right?
Yeah.
So I can say, 1 over 3 factorial equals f prime double prime of 0 all over 2 factorial. Then what does f double prime of 0, what must it equal? Oh. Multiply the 2 factorial over 3 factorial, which is 1/3. That's true. Right? Which is 1/3. What's f triple prime supposed to be? Well, f triple prime is supposed to be over who?
3 factorial.
3 factorial, right? But who is he actually?
1 over 4.
So multiply up 3 factorial over 4 factorial, that's going to be 1/4.
So
So
n minus
who
1
knows
over-
what 1/10 is going to be?
X to the 10.
Close. Third derivative is going to end up being 1/4. Second derivative is going to end up being 1/3. Therefore, 10th derivative is going to end up being 1/11.
You did it!
That's fun. Anyways, that's
You
A.
did it, Joyce. It was so easy.
But I think that was one of the ones that we have not practiced, and this is one of the ones that I was like, hey, it gets tricky. All right, kiddos, I am ending this for
Yay.
today. We are basically done now.
And,
So, I'm going to go ahead and stop the recording. Bye, Joyce.